right, hello everybody, and thanks for coming to my pitch. I want to start maybe by talking about Hurricane Harvey. I don't know if you remember, in the fall of last year, we had Hurricane Harvey in the US, and there's three shocking aspects of Hurricane Harvey that I want to point out to you. Aspect number one, it was the costliest natural disaster in US history ever. I don't know if you know what the combined loss was, but it's estimated at about 180 billion US dollars. And that's financial losses in one climate change driven event alone, 180 billion. Now, if you find this number shocking, I'll tell you a second point, and that is you all lost money on this event. Actually, we all did, and the reason is because our pension funds are all globally invested, and they're invested into companies that have operations in Houston and have lost money on this disaster. So I'm asking you a rhetorical question, and that rhetorical question is, would you want your pension fund portfolio managers to look at these kinds of risks? Of course you would like to, I assume. And the shocking point number three is, if your pension fund portfolio managers look into their typical Bloomberg, Reuters, whatever terminal where they manage your portfolio, there is zero climate risk information. And this is where Carbon Delta comes in. We have built Climate Value at Risk, which is a risk management tool for the asset management industry to manage climate change risks. So maybe to come back to introducing myself, as you know, Daniel said, my name is Oliver Marchand. I come from Zurich, Switzerland. I quit my job well, maybe I should start out by saying that I originally was working in weather forecasting. Unfortunately, not on TV. That, you know, in Germany, some people have become very, very popular and made a lot of money with weather forecasting. I was always behind a computer screen working on weather models. But I got a little bit bored working for weather services, so I switched into the financial industry and led the IT department of an asset manager in Zurich for about 10 years. And when I saw the first, let's say, CO2 numbers pop up in terminals, I was thinking, well, sadly enough, climate change is here to stay and is probably going to increase in its effects. So something like climate value at risk, it became immediately obvious to me that that would be what the financial industry would need. So I quit my job, and I was thinking I should look for people that are like-minded, and I applied for the Climate Kick Accelerator program. I was admitted to it mid-2015, and that was really the birth hour of Carbon Delta. That was what really motivated me to really start the company, and Climate Kick has been with us, or me, all this time, and I'd like to, at this point, also thank you, Climate Kick, for the support, not only in the project collaboration, but also the psychological support. It's been really a fantastic journey. So Carbon Delta was then founded in 2015. In 2016, we were lucky enough to do a big project for Swiss Re, working on building computer models for their insurance portfolio. And then in 2017 was mostly where we built this climate value at risk system. And yes, I think our flagship project last year was with AXA. It was just released. AXA analyzed their whole investment portfolio with us, and I'll talk a little bit about that later. Carbon Delta is not at all only me. We're a dedicated team of about 15 employees now. Most of us are computer geeks or climate change experts, and we're mostly focused on building these computer models to assess climate risks. So I want to talk a little bit about what climate value at risk actually is and why it's so different from what's on the market today. So in the financial industry, if climate change plays a role at all, then what's usually being done is carbon footprinting. And while from an environmental point of view, this is extremely important and very interesting, it's looking at the effect of the portfolio onto the climate. It's not very aligned with the portfolio manager's goal. And let's be frank here, the portfolio manager's primary goal is to generate return. And if somehow the analysis of the carbon footprint is not in line with generating these returns, there's obviously a problem of making that a standard in the financial industry. Well, we thought, how can we overcome this problem? And we have actually turned the whole story around. And we've looked at what is the impact of climate change onto the return of the portfolio. And so it's a very different metric. It's in the value space. It's a forward-looking metric, whereas carbon footprinting is often backward-looking. What were the past emissions? And that's, I think, the main reason why it's so interesting for financial institutions that have previously not gone very much into climate analysis now to use climate value at risk as their tool. I want to talk a little bit about what companies or what financial institutions actually do with this data. And I think the number one use case is compliance reporting. You've probably heard about the TCFD initiative. That has created a lot of interest in corporates and financial institutions to assess their climate risks using climate value at risk. And one of our major markets is obviously in France, because in France there is, as you might have heard, the Article 173. And the Article 173, it's the energy transition law in France, and it has also a part that talks about the financial industry, and any asset manager in France that manages more than 500 million euros has to report to the government their analysis of their climate impact and risks. And risk, again, can be best measured, in our view, with climate value at risk. Then, of course, we did some backtesting studies. Backtesting in the financial industry is all about looking at, well, what if I would have invested in a certain way in the past? What would I have generated in terms of return? And the interesting point is always what's called outperformance. Most investors invest using benchmarks. You've probably heard about the typical benchmarks like MSCI World or the FTSE 100, or in Germany it's the DAX, in Switzerland it's the SMI. It's a broad set of companies that you would invest into. And we have done backtesting analysis on the S&P 500 with the University of Lausanne. And if you would have invested using climate value at risk over the last 5 years, using the S&P 500 as a basis, and you would have invested into the climate champions of the S&P 500, you would have outperformed the S&P 500 actually by 16% over those 5 years. That's considerable outperformance, and that is actually proof of saying that climate change risk analysis does give you additional return currently even. So that's just motivation for financial institutions to actually create financial products based on climate value at risk. Then some financial or some asset managers, they actually use something called shareholder engagement to fulfill their sustainability goals. Instead of saying, you know, they divest and invest their money in a certain way, they want to influence with having shares actually in quote-unquote bad companies. They want to influence the companies in the annual shareholder meetings, and our data is quite well suited to generate shareholder engagement campaigns, because everything that we do results in an effect on the shareholder, potential loss of the shareholder, and it's in the best shareholder's interest at annual shareholder meetings to ask the company if these potential costs and these scenarios that we have are actually ever have been accounted for. So we have a number of campaigns based on climate value at risk. And then, of course, I mean, it's just very normal now that financial institutions start integrating climate change into their overall risk management, and that's another very good use case. So how does that work in practice? How do we, in practice, actually calculate climate value at risk? My background is in computer science. You know, I hope I don't make it too complicated, but I want to be very specific about what we do. I think it's the most interesting point. So I'll try to explain exactly how climate value at risk is calculated. Well, the first thing that we do is we have a database, and that database basically has two types of information in it. Obviously, it has a lot of information on climate change. That information is, for example, we have quantified all of the NDCs. We have business as usual trajectories for all countries. And it also contains a lot of financial data. So we have data on over 20,000 companies in our system. It's mostly data that we get from FactSet. We have a close collaboration with FactSet. FactSet is in the financial industry very well known because they're the number 5 in the world for financial data. So they're like Bloomberg and Reuters, but not like the biggest ones, but the number 5. And that's why we have, that's why we can model so many companies, because we have this data from FactSet. Now that's the first of 4 steps. Then in the second step, what we do is we calculate costs. And you can imagine such a cost, for example, can be an emission reduction requirement of a company multiplied by an assumed carbon price. So let's say, for example, we analyze Heidelberg Cement, a German global cement manufacturer. We know they emit maybe 10 megatons per year in Germany. We know that to achieve the NDCs, they have to reduce it by 1.5 megatons. And we get from the Potsdam Institute, values from their Remind model for assumed carbon prices in 2030. Then we know we can multiply these 1.5 megatons with the carbon price of maybe 40 or whatever it is in the Remind model for Germany in 2031, and we get a price. And we assume that if that price is not accounted for in the share price of Heidelberg Cement, then this would have to be paid by the shareholder. So you can multiply 1.5 megatons by the carbon price, and of course every scenario in our system has a different formula, but the idea is the same. 15 years into the future, we calculate cost profiles onto companies. And then there comes the third step, and the third step is something that probably you're not very familiar with, but these types of costs, there are classical financial models that tell you on these assumptions what the impact onto the price of a security is. So if I hold a stock of a certain company, or if I hold a bond of a certain company or another asset, then there are typical financial formulas to look at what the impact on the price of that asset is. And that's what we do. We do this financial modeling, and that result, this relative valuation, for example, for Heidelberg Cement, maybe it would mean being compliant with the NDCs, that would be a drop in share price by 21%. That is climate value at risk. And then in the fourth step, and that's the nice, climate value at risk has a few nice properties, and that's why you can do step number 4, and in step number 4, you can aggregate it across a whole portfolio. You can look at the sectors in your portfolio, you can set targets and all of this, and you can also compare it to other risk metrics, like, for example, currency risk or default risk or things like that. These are 3 unique characteristics which make it very interesting for the financial industry to use it. I want to talk a little bit about what scenarios we have in our system. We have mainly 3 scenarios. One is we have a family of policy risk scenarios. We have an NDC scenario, a 2-degree scenario, and a 1.5-degree scenario. And in each of these policy risk scenarios, we look at what if policy for emission reduction is going to be in place, and these companies are going to have to pay for these emission reductions. What would the impact on the share price be? And that is basically saying that they wouldn't only directly pay for these policies, but it would be a proxy for anything that you could do to lower your emissions. It could be technology change, it could be buying carbon offsets, it could be going into another business model, it could be any of these or other ones. Then we actually have a technology opportunity scenario in our model, and we're very excited about that. And what we actually do, it's a combination of patent analysis and also scenario analysis. And what we do is we've loaded a database of 30 million low-carbon patents into our system. We've mapped them to the 20,000 companies that we have in the system. And the nice thing about these patents is that the UNFCCC have actually established a system to mark patents as low carbon and to actually categorize them in 400 different technology groups. So we know exactly what kind of markets, future markets, patents are always valid for 20 years into the future. These companies have actually protected. And we think that is a much better proxy for the preparedness of a company into a low carbon future than looking at qualitative marketing material. If you look at companies like Exxon or Shell, how many times in the last 20 years have they claimed they will, deeply go into renewable energies, and nothing has ever really happened. And then we also do a lot of physical risk analysis. Physical risk analysis is what I talked about in the beginning, Hurricane Harvey. We currently have in our model extreme heat, extreme cold, heavy precipitation, snow. We have heavy winds. We actually have tropical storms. We're about to integrate sea level rise now and wildfire. And we do most of this work in close collaboration with the Potsdam Institute. We're very proud that we were featured this year in PIC's last year's annual report. You can see on page 16, there's half a page about our collaboration in the PIC report. Well, I think almost 20 minutes are over. I'm going to stop here, and I'm ready to take questions.
Thank you very much, Oliver. That was very interesting. And certainly, I think, a big area of growth coming up. I just wanted to ask quickly before we turn to the audience a question on the growth. You mentioned the law that's now in France around disclosure and assessment of risk. Do you see other countries adopting? Do you see other European countries moving in the same direction? And what would be the impact on carbon delta?
Well, I can certainly say that we see similar initiatives in Canada, in the EU, and in Australia. And I can just see on a very high level that a lot of countries are debating this. A lot of, let's say, more greener left-wing politicians, I think, are very fond of the Article 173 and see it as really a major breakthrough. So I would expect something like that to be launched quite quickly in other jurisdictions as well. By quickly, I mean maybe within the next 2 to 5 years. In Europe, it's specifically the IORP2 directive. I think that will take effect in 2019, hopefully. And of course, we are totally betting on that this is going to happen. And I think if it would open up major markets for us, I'm sure.
Any questions or comments in the audience? One coming round to you.
Just wondering how relevant it might be for corporates. Is it all for asset managers, or how applicable can this be for corporates?
Well, we have a couple of corporates working with us, and I would say for corporate, our analysis might be a little bit broad in a way, not too detailed. So obviously, it's always possible to refine the analysis with internal data from companies. Yeah, we work with a couple of corporates, but it's not our main market where we're trying to do marketing. But the system, in principle, of course, is possible to refine with corporate data, and I think it's a very good, let's say, start for corporate. If you wanna, if a large multinational corporation would like to start doing something like TCFD reporting or climate change risk management on a strategic level at all, then I think our analysis is a good start to have something to look at rather than building everything from the very start and rather than optimizing what we have.
I have another question, and that is, you talked a little bit about the opportunities. You talked quite a bit about how it helps identify risk. I was wondering if you could talk a little more about how the program can help identify opportunities for companies to invest.
Yeah. Well, the Remind model is an integrated assessment model, and I would assume that most people here are familiar with these integrated assessment models. And the interesting point about these integrated assessments models is that for, let's say, for example, a 2-degree scenario, they deliver, depending on the model, quite detailed data on what the energy mix will be, what a technology mix will be, what emission reduction requirements are. So we can really look at what impact would that have on the needed emission intensity in a large number of different business sectors. And of course, if there are emission intensity targets, then you can assume, make an assumption on how much of that of the total business would have to be covered by low carbon technology. And that's a very, very good pointer for looking into the future, what the potential revenue and profit potentials are of the different scenarios. And we take these and we look at what is the patent situation in that specific technology sector, and we just split up over time the protected market. We assume in the scenario that these revenues and profits are going to be shared exactly as the patent value is being shared by the company. So if you own 50% of the total of the global patent value in a certain technology, then you also, in our model, get 50% of this future potential green revenue. And I would like to really point out that the big difference between this and a specific analysis, and I want to point that out because many financial institutions ask us if we can provide a special analysis for them on the automobile sector. And I think the point is that we as consumers, we see Tesla, we saw up until now, a great potential to invest into these types of electric vehicle producers. And so the focus is on there. But I would just like to point out that the number of low carbon technologies is just staggering, and that there were actually technologies in these 30 million patents that we had never thought about. I mean, that includes nuclear fusion, that includes alternative meats, that actually includes new replacement technologies for cement. I mean, there are so many that you would not think of if you did a specific analysis on even a larger number of technologies.
I was wondering if you could speak a little bit about your result with your the result of your collaboration with AXA on Article 173.
Yes. So we worked with AXA on writing their last year's Article 173 and TCFD report. You can actually find it online and see the results for yourself. It's about a 70-page report, and I would say about half of it focuses around our climate value at risk analysis. We mostly focused on equity, meaning the stock market, and corporate bonds issued by companies, not by sovereign states. We have in total analyzed a portfolio of 230 billion euros, and that portfolio included around 130,000 different securities globally from all over the world. And I think we're quite proud in saying that we believe that this is the biggest climate risk analysis that has ever been done. There has been a lot of climate analysis done, maybe also of larger portfolios, but this kind of climate value at risk, where we've actually really looked at what is the financial pricing risk for the investor, I think this is the largest study ever.
I see there's one more question over there, Rihanna.
Just going back to what you said about those patents, how do you incorporate that into the modelling? Because each one is quite unique and distinct.
Well, the good thing is that it's a very good question. So, first of all, one of the good things is that starting about 10 years ago, the European Patent Office started a project where they merge all of the national patent databases into one global database. It's called PatStat. It contains about 90 million patents. The second thing is when you're a patent lawyer and you file a patent for your company, what you then usually do is you check what technologies can you file this patent for, and you actually pay for each technology sector that you're filing something for. So let's say, for example, you have a great little technical application to reduce electricity consumption. Then you can actually use that in transport. You can use it in electrical grids. You might be able to use it in engines. And so then for each of these applications, you would file what's called a code. Let's call it a code. And there is a system established by the UNFCCC. It's the Y02 and Y04 codes, and they just pertain to low carbon technologies. And that comes with the patent database. So actually that's not analysis we did ourselves, but that comes included in the database. So that's why I said 400 different technology groups. Actually, there are more than 10,000 of these Y02 and Y04 codes, and we've just reduced them to the 400 main ones. And so we know for each patent what technology sector that patent is applicable to. Does that answer your question? We know exactly, is it in solar energy? Is it in transport? Is it in, whatever? Is it batteries?
All right. Thank you very much. We're actually out of time. So please join me in thanking Oliver from Carbon Delta.
All right. Thanks very much.